In this example, we're going to compare the performance of the geometric mean to the arithmetic mean and determine which is a better investment, A, B, or C. Okay. Now, one thing really important to point out here is that this value right here is 1.39%. In decimal, it's 0.0139. So it's really important to point that out because the units here are percentages, right? So we're missing the percent symbols here, right, on all these numbers. So that's the first thing we want to point out, though. All right. So when we're copying this data into Excel, to preserve the table formatting, you want to not you don't want to get just the information inside the table. You want to get something outside the table because sometimes when you paste it into Excel, you'll lose that table formatting. So I'm going to copy this whole thing over here to Excel, and then I'm going to widen these columns up, and then I'm going to line left justify. Okay, so real quick here. This right here is actually, this value here is actually in decimal form. It's actually equal to 1 divided by, or it divided by 100, right? So this is what these values actually look like numerically, right here, right? And if you want to convert them to percentages, you can do that by just clicking on the percent and then adding some decimal places. Okay, so the percent symbols are missing here because the column header has percent in it, right? But when you report these percentages in a table like we do over here, it just gets a little cumbersome. So what we do is we get rid of the percent symbols and we put the word percent in the column header, right? That's really important to note real quick, right? I'm going to go ahead and delete that, and we just note that these are percentages. So they have to be converted into decimals, right? When we're doing the geometric mean. Okay, so the arithmetic mean is pretty easy. All we have to do is type equal average and then highlight the observations there, right? So this is actually, numerically, this number is actually 0.01045, or 1.045%. But again, the column is in percentages, so we know that that's 1.045%, which is equal to 0.01045. We can copy that to here. Oh, down here it says to use 2 decimal places. So let's do that. Let's just reduce this to 2 decimal places. So it's 1.005%. 1.05%. Okay, now the geometric mean is a little more difficult to compute. What we need to do is we need to convert each one of these to decimals, and then we're going to add 1 to it. So the first thing we want to do is we want to divide that 0.73 by 100, right? And then we want to repeat that process for each one of these. So what I'm going to do is I'm going to copy this right here, and I'm going to paste it, but then I'm just going to move this down. See that? I'm going to paste and then move it down. Oh, move it down. There you go. Paste and then move it down. Paste, move it down, paste, move it down. And we should have 6 of them, right? 1, 2, 3, 4, 5, 6. That's probably the easiest way to do it. Now the next thing to do in the geometric mean is to raise this expression here to 1 over the 6th power. And to do that, we're going to put a parenthesis at the beginning and a parenthesis at the end. And then we're going to go to the end, and we're going to do raised to a parenthesis 1 divided by 6. And then the last thing we have to do is subtract off 1, because we've added 1 to each one of these percentages. We now have to subtract off the 1. And this gives us our geometric mean, which is really close to arithmetic mean. If we convert it to percentages, once we convert it to percentages. So what we have to do now is we have to convert this into percentage. We can click on percent here, or to be consistent with our table, instead of convert it to percent by clicking on that, we can just multiply the whole thing by 100. So what we need to do here is we need to do 100 times, and then there we go. Let's put this in here so we can see it. So this parenthesis right here, if I go back and forth on this parenthesis, you can see it corresponds to this parenthesis here, right? See that? It kind of blinks over there on the right. And then this parenthesis here corresponds to the one right here. See that? And then each one of these is closed out. So we have just the right number of parentheses, open or closed, and they're in the right position. So we can hit enter and we can convert it to percentages. You can see that the geometric mean is pretty close to the arithmetic mean. And the reason why that is because these numbers are all relatively stable. There's not a lot of variation in them, right? However, they're not completely equal. They're not equal to 2 decimals because this number is about half of that number. So it doesn't look like there's much difference, but this number is about half that number. If I multiply 0.73 times 2, I get almost 1 or just over 1.39, right? So now what I can do is I can just drag these two over here, and I can see that these two numbers are really close together, right? These two numbers are really close. They're not equal, but they're pretty darn close, right? They're equal to, looks like they're equal to 2 decimal places, right? And the reason why that is because 5.87 is, in terms of percent, is pretty close to 7.43, right? This is half of that. This is much closer to that as a ratio, right? So that's why these two numbers are really close to each other. So if these returns are really stable, there's not a lot of volatility, the arithmetic mean is a good choice, right? It's a good estimate. Now we pull this over here to the investment portfolio C, and we can see that, man, there's a problem with the arithmetic mean. It's way overstating it because it's giving these values more weight than this last value. And this last value is saying that the investment, no matter how much it's increased by, right? So maybe it increased from 1,000 to 2,000. It's going to lose 50% of its value that final year, right? So this last year should have a lot more weight on the average. And the arithmetic mean weights all these equally when this should have the most weight because the investment's growing in value, then all of a sudden you get a 50% reduction. So there's a time dependency here, and that's why the arithmetic mean is way overstated. Okay? All right, so we can plug those numbers into our table here. So this is 1.04. And then we have this is 1.04. And this value is 6.64, both arithmetic mean and the geometric mean. The arithmetic mean is 10.08 here, and it's 4.55. 4.55 there, right? Okay, good. We'll set that Excel aside. Okay, so if you use arithmetic mean to evaluate the investments, you would choose investment C is the best, right? Because it averages 10.08%, right? If you use the geometric mean, you're going to choose investment B because it has the highest geometric mean, right? And it's averaging 6.64 a year. Okay. If you recommend people, if you tell people that they should have purchased C, you're not going to have your job very long. And it's because of this time dependency in these returns. Okay. Now down here we have $20,000 to invest at the start of 2018. So what I'm going to do is I'm going to put this $20,000 right here. Oh, I'll put it in Excel right here. Okay, I'll put it in all three columns. So we need, that's the start of 2018. And we're going to calculate the value of the investments after each year. Okay, so the investment is worth what after the year 2018? Well, to get that, we have to multiply 20,000 times 1 plus, but this has to be converted into decimals, right? So we have to divide it by 100. So after 1 year, that $20,000 turns into 20,146, right? Let me change the, let me add commas here. Yeah, there we go. Then we'll get rid of the decimal places. We can add them in later. Okay. So after 1 year, this return is not very big, so we're only going to get up to $20,146, right? And then I can pull that across and we can see how all three investments do after 1 year. After 1 year, the best investment is B, right? Okay, so now let's pull this down here like this and see what's going on. Now we're taking this 20,146. This is the art of compounding, right? This is why the geometric mean is preferred to the arithmetic mean. Now we're the investment's grown at 0.83%, right? 0.83%. The word percent just means per 100. Cent means 100, right? So 0.83%, right? So now investment A is worth $20,313. Investment B and C are worth $22,476, and it looks like C is almost caught up to B, and that's because there's a huge increase in C in year 2, right? So you got a much bigger increase in year 2 than did investment B. So we can just drag these down now. We're going to drag them down to the year 2022, right? This $20,742 increased by 1.22% from 21 to 22. And then this 25,555 increased by 7.11% from 2021 to 2022. And then we had this massive increase in investment C. It went from 36,000 to 52,000 because the year-over-year percent increase in its value was 43.45%. So in the year 2022, man, we would have done really well in investment C. But then the year 2023 comes and we have a small increase in investment A. We have a pretty good increase in investment B, but we have a massive drop in investment C. So in that year 2023, we can see that, oh wow, investment C is only worth $26,000. Investment B is the best performing investment after the 6 years. That's weird. Is it because I got this number 14? Okay, there we go. All right. Let's do a left justify. There we go. Now it's all lined up. So the best performing investment is C, right? The worst performing investment is A. The one in the middle is C, and that's why you want to go with the geometric means, right? If you want with the arithmetic mean, that discounts this final year performance because it's equally weighting these performances, right? And that's just not the case. So this illustrates why the geometric mean is the mean that you should use when you're looking at investment portfolios or anything that has a dependency through time, right? When there's lots of volatility, it definitely matters. When there's very little volatility, it doesn't matter, right? Okay, cool. So at the end of 2023, our investment options are these values here, right? So we're going to copy this into here. We need 2 decimal places, though. So let's make this 2 decimal places. So that's investment A. We got to get investment B. And then we got to get investment C. So you definitely want B, right? It would have been much better to have B than C. Okay, now we need to calculate the expected 6-year return on each investment. And this is just a percent change. So we're going to calculate the percent change. We're going to take what it is in the year 23. We're going to subtract off what it was at the beginning. And then we're going to divide by what it was. And then we got to multiply by 100, right? To convert it into a percent. And we only want 2 decimal places. So let's go up here to get the decimal places. Okay, and then we'll drag this across. So 6.43. So over the 6-year period, A went up 6.43%. B went up 47. Whoops. I got it copied wrong spot. And then C only went up 30.58%, right, over the 6-year period. Okay, now we got to annualize above returns, but we're not going to divide by the number of years. What we're going to do is we're going to convert it using the exponential version. Okay, so here's an equation for it. This is our cumulative return. We just calculated that. We got to add 1 to it, and that gives us our annualized return. So, and then we got to subtract off 1. 365 is 1 year, right? And we have it for 6 times 365. So we can think of this in terms of years instead of days. So this would be 1. And this down here would be 6 times 365, right? So 1 divided by 6. That's the equation we're going to use to convert this multi-year return into an annualized return. So if we come back here, I convert the cumulative return into a decimal, right? So this is 6.43%, right? And I add 1 to it. Then I raise it to the 1 over 6 power because I'm going to hold it for a year. And then I've actually held it for 6 years, but I'm going to convert it to 1 year return, right? And then I'm going to subtract out the 1, and I get the annualized return. Now, I got to convert this to a decimal. And one way to convert it to a decimal is to just multiply it by 100. So I'm going to multiply the whole thing by 100. So I get 1.04%. Shrink the number of decimal places to 1. So you can see these annualized return. This is the 6-year return, and this is the annualized return. You can see that these are equal to the geometric means. See that? Another reason why the geometric mean is more appropriate, right? So this is the 1-year return. So let's go back to our problem. Okay, so investment A has an annualized return of 1.04%. B is 6.64. And then C is 4.55. Or 4.55, sorry. Okay, looks like those are all good. And then I've already explained this, so I've explained this, so I'm not going to type anything here. I'm going to go ahead and hit submit and just make sure that I got everything correct. It looks like I got everything correct here. Okay, and then I'll grade your response here.